Today we'll continue talking about circles. Today we're going to focus on arc measures. Learn what arcs are and how we can figure out their measures. So first of all, we need to know the difference between what an arc is. What is a major arc? What's a minor arc? And what do we talk about when it's a central angle? So in talking about that, the central angle is the angle whose vertex is in the center of the circle. So for example, angle ACB is a central angle because C is in the center of the circle. A minor arc is an arc whose measure is less than 180 degrees. So we'll say minor arc AB, and when we label it, we'll put the little arc measure over the top of the 2 points. And major arcs are arcs, use a different color here, arcs whose measures are more than 180 degrees. So for example, ADB is a major arc since it's more than 180 degrees. And we use 3 points for the major arcs. And just like when we're naming angles, it goes in order. So A, D, B, just like it's written. So we'll explore in GeoGebra how we figure out what those angle measures are. So you can click the link if you want to explore as well. It's found on the website. Okay, so if we take a look at some of these central angles, I'm just going to drag some of these points around. And I do that by moving the slider up here. So I can change my central angle. You can see angle BAE changes. If I try to make a straight angle, I can't quite do that, but I can make BAE a right angle. I know that's 90 degrees. I can see what that measure is, and I know if it's 90 degrees, I can see that it splits this circle into 4 equal parts. And I know that there's 360 degrees in a full rotation, so I know this arc measure will also be 90 degrees. So the arc measure will be equal to the central angle that it connects in between here. So if I open this angle up to 45 degrees, or close it to 45 degrees, I know arc BE will also be 40 degrees. So a thing to note here would be, well, the measure of arc BE, it's a minor arc, since it's less than 180, would be 45 degrees. And that would mean that arc E, I could call it ECB, that would be 360 minus 45. So that would be 315 degrees. So hopefully that makes sense. We got that connection between the central angle and the arcs. So let's record some of that information that we've talked about with arc measures. When we measure arcs, we're measuring its central angle. So the measure of arc AB is read just like I read it. So the measure of the entire circle we mentioned was 360 degrees in a full circle. And the measure of a major arc is the difference between 360 and the related minor arc, as I showed. So when we have minor arc AB is 50 degrees, I know that the related arc, the major arc, ADB, will be 360 minus 50, because that's how much is left over. Semicircle is 180 degrees. So I'd like you to pause the video and figure out if you can find the measures of these arcs. Restart it when you're ready to check it out. So the minor arc DE is 117 degrees because that's what its central angle is. DFE, the major arc, goes from D, goes through F, finishes at E, would be 243 degrees. So you have 180 for the semicircle. And these two angles are a linear pair, they're supplementary. So they add up to 180, so that means this angle is 63. So 180 plus 63 is 243. And then DEF is that semicircle, so it's 180 degrees. Now, just like we've talked about with segment addition and angle addition, arc addition follows that same format, the same rule. So the measure of major arc ABC, well, I could break that down into the measure of arc AB plus the measure of arc BC. Since I can break it into those two sections, you can see that AB plus BC make up arc ABC. So take a look at the circle graph and see if we can find the measures of the indicated arcs. Pause the video, restart it when you're ready. So to find the measure of arc BD, that's a minor arc. So to get from B to D, I have to go counterclockwise, because that'll be less than 180 degrees as opposed to the other way. So 55 plus 105 is 160. And then BCD, that's a major arc more than 180, that's 200 degrees. So next we're going to take a look at if the arcs are congruent. Now arcs are congruent if they have, we know the term of congruent, same shape, same size. So do the arcs have the same shape and the same size? Do they have the same measure? Are they in congruent circles? So BC and DE have the same measure since the central angles are both 75 degrees. And since they're both in the same triangle, they have to be the same size, so they are congruent. AB, arc AB, since its central angle is 80 degrees, AB is 80 degrees. And CD also has the same central angle, so it's also 80 degrees. But the circles are not congruent. They have different size radii. So we would have to say that those arcs are not congruent. And then arc FG and arc HJ. Their central angles are both 90 degrees. The radii of the circles are both congruent. So we'd have to conclude that the arcs are congruent as well, since the circles are congruent and they have the same measure. So in the diagram at right is PQ, arc PQ congruent to arc SR. Well, it's similar to this example here. They're in the same measurement of the, central angle. There it is. So they have the same central angle, PQ and SR. So that means their measures are the same, and they're in the same circle, so yes, they would be congruent. Now let's finish up by talking about some more properties of congruent chords. In the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we can kind of take a look at that by if we had the center of this circle. Well, if these arcs were congruent, it would have to mean that they would have the same angle measure for their central angle. So if these central angles were congruent, well, then I would know that what would we have? We'd have an angle congruent, and these are radii. So this radius would be the same as this one, and that would be the same. And this chord forms, yes, you guessed it, another triangle. So by side angle side congruence, we know these two triangles are congruent. And if the triangles are congruent, corresponding parts would also have to be congruent. So that proves why this theorem works. So just keep in mind always that if we have two circles and their minor arcs are congruent, then we know that their corresponding chords would be congruent. So let's take a look at some of these examples here. So if we know E is the center of the circle, segment AB is congruent to segment CD, take that information and why don't you work through some of these problems. When you're ready to see the solutions, press play again. So go ahead. Okay, so there are your solutions. If you'd like a little bit more of an explanation, I can do that for you. Otherwise, that would be it for today. So if AB arc is 40, well, I know CD would have to be the same because we have congruent chords, so the arcs would have to be congruent. If measure of 1 is 88, well, what is arc AB? Well, that's the central angle, so it's also going to be 88. If BAD is 215 and angle 2 is 120, so that would mean DC is 120. That would mean that AB is also 120. So I could just subtract 215 minus 120 to give me arc AD. of 95 degrees. The next one we're taking a look at, if BD is 140 and if AB is 110, what's BC? Well, if I know AB is 110, I know CD is also 110. So that leaves only 30 degrees for BC. If measure of arc AB is 6x minus 1, and CD is 3x plus 20, well, I know those two arcs are the same, so I can set an equation. 6x minus 1 equals 3x plus 20. And then I solve for x. 6, 7, 8 are very similar to that. Number 6, I have measure of angle 1 and measure of arc CD. Well, I know those are going to be the same because I know arc AB will be the same as arc CD. So I would set 4x minus 3 equal to 2x plus 71 and solve for x. Measure of angle 2 and measure of arc AB, that's just reverse of the other one. So I know those measures will be congruent, so I set those two equal to each other. 9x minus 7 equals 2x plus 21 and solve for x. And finally, number 8, measure of angle 1 is 7x minus 8. Measure of angle 2 is 3x plus 36. Well, since I know these two chords are congruent, and the radii are congruent, once again, two congruent triangles, so corresponding parts will be congruent. Angle 1 will be equal to angle 2. Solve for x, and we get 11. So today we talked about how to find the angle measure. We talked about that the angle measure, whether it's a minor arc or major arc, is equal to the central angle that encloses that arc. And we know that the arcs, as long as they have to be congruent, if they're the same shape and size, they have to be in congruent circles. We also touched on the arc addition postulate, which was similar to that segment addition and angle addition postulate that we've talked about in earlier units. So you can get to work on some of the practice in class, and I'll take any questions you might have.